Hello, everybody. We're going to do some matrices or matrices. Um, and basically what we're trying to do is we're trying to learn how to solve an equation, like we see in number 19 and following, where you've got, here's a matrix. We want to multiply it by something. We're not really maybe sure what we would multiply it by. And then we're hoping to get another matrix that's a 2 by 1 with 24 and negative 33 in it. So we can't just divide by a matrix. It's not a thing. You're not able to divide by a matrix. You have to multiply by the inverse. So first step, we got to be able to find an inverse. Well, that's not really the first step, because to get the inverse of a matrix, you first have to find the determinant of the matrix. So like a determinant of 0 means that there isn't an inverse. But it's a fairly simple problem for 2 by 2 matrices. It's a not simple process for 3 by 3s. So I will show you how to do those as well. All right, here we go. Okay. So I'll look at number 3. Basically, if you want to find the determinant, come on, thing. Does not want to. Of this matrix is you do, it's kind of a cross multiplying kind of thing. You do negative 4 times negative 8. Minus negative 3 times 1. This is going so well. So that turns out to be 32 minus a negative 3, which is just plus 3, which is 35. So that is the determinant of that 2 by 2 matrix. And I do want to see you do the actual math to get there, the actual operations, but there's a way that we can check that. So I'll move my face. So if you hit second and the x to the negative 1 button, it takes you into matrix land. And if you hit the over to the right arrow, you can get to math, and you see DET, that stands for determinant. So we can find the determinant of this matrix. We just have to enter the matrix. How do you enter that? Alpha and zoom. And then we have to choose a 2 by 2, and mine already has 2 by 2 selected, so I'll hit OK. Negative 4, negative 3, 1, negative 8, and we see that it's 35. Okay, so let's do a 3 by 3 real quick, and I'll show you how to do those. So I want you to do the 2 by 2 by hand. Doing a 3 by 3 by hand is pretty tedious. I mean, practically speaking, I just don't think that it's something we need to do right now. So we're going to use our calculator to do it. 3 by 3. Same thing. Go to determinant, alpha, zoom. This time I need to go up and select a 3, 4. One. Almost there. And boom. The determinant of this one is 112. So that's the determinant piece. So you may go ahead and do all of those, and then we'll jump into finding the inverse of these matrices in just a moment. All right, let's use number 13 to find the inverse of this one. Okay, so first step in finding an inverse is to find the determinant. So we need to find the determinant of this matrix. And the way we do that, we do negative 8 times 10, which is negative 80, minus negative 4 times 8, which is negative 32. That's just negative 80 plus 32, which is negative 48. All right, now here's where it gets a little bit complicated maybe. So if we want to do the inverse, we have to find, we do 1 over the determinant, 1 divided by the determinant, times, not this matrix, but kind of this matrix. And remember, we are trying to do the opposites or the inverse of all of these steps that the matrix would perform normally. So this is what it looks like. These two things, the top left and bottom right, are going to switch places. So 10 goes to the top left, negative 8 goes to the bottom right. The other two are going to stay in the same places, but they're going to change signs. So it's going to be a negative 8 down here and a positive 4 up here. Just trust me. That's what they say, huh? And now this is just a scalar multiplication problem. So we're just going to multiply everything in this matrix by negative 1 over 48. And when you do that, you can use your calculator to do that. You get negative 5 over 24. You get negative 1 over 12. You get 1 over 6 and 1 over 6. So you can break out the whatever you want to do. And this is your answer. For the inverse matrix, look at this thing just messing up. The inverse matrix on number 13. Okay, so now what does that inverse matrix do? Well, first of all, let's go to our calculator. I'm going to show you how to do it in the calculator. Don't you worry. So we're going to go second math again. Actually, no, we're not. Second, not. Let's do alpha zoom. We're going to enter in this matrix. Negative 8, negative 4, 8, and 10. So there's the original matrix. Now check this out. If I hit this little up arrow, actually I don't have to hit that. The matrix button, x to the negative 1, hit that. That little negative 1, talked about it before, means the inverse. If you look at sine, cosine, and tangent on your calculator, they have little negative, sine negative 1, cosine negative 1, tangent negative 1. Those are inverse sine, cosine, and tangent. So if I hit enter there, it gives me all this mess. These are repeating decimals. If you hit math, enter, it's going to turn that matrix into a fraction, or all those decimals into fractions. And you can see, now you can see that matches the matrix that I have. So what can we do with that matrix? Well, if we take the inverse and we multiply it by the original matrix, and remember, when you multiply matrices, the order matters. So putting the inverse matrix first times the original, we get what's known as an identity matrix. And if you multiply by an identity matrix, it's just 1. So the same way with fractions, we want to do, if I wanted to get rid of oh my goodness, if I wanted to get rid of a 2/3, I could multiply it by 3/2, because 2 times 3 equals 6, 3 times 2 equals 6, and 6 divided by 6 equals 1. And so basically these we would kind of cross them out and say these things cancel out. We're doing the same thing with a matrix. If we multiply it by its inverse, then they just go away, and whatever's left behind, let's go back down to 19. If we can multiply the right side of this equation by the inverse of this matrix, then we're just left with x. Do to one side what you do to the other, so we would have to multiply this side as well by the inverse of this matrix. And once we do that, we find out what x is. So let's go ahead and do that. Sound like a plan? Okie doke. Step numero uno, let's find the determinant of the matrix that is that's boxed in blue. So that is just going to be 1 times 7 minus negative 5 times negative 2. So 7 minus 10 is negative 3. That's the determinant. But to find the inverse, so we're going to find the inverse of this matrix, we're going to do 1 over the determinant, which is negative 3. So that's just negative 1/3 times 1, nope, these two switch places, 7 and 1, and the other two switch signs. Switch places and switch signs. Now we multiply. We get -7/3. We get -2/3. We get -5/3. Oh my goodness. And -1/3. All right, so this is the inverse of the blue matrix. And if we multiply them together, then this and the inverse matrix cancel each other out, just leaves us with x. So x is equal to what? It's equal to the inverse matrix times 24 -33. Okay, so we've got a 2x2 matrix that's being multiplied by a 2x1 matrix, which means every location or every address is going to have two numbers, two multiplied numbers being added to each other, and the result should be a 2x1. It should be two rows, one column. All right, so I'm going to try to write these in here if I'll fit. -7/3 times 24. Wow. Plus -5/3. My goodness, I am not even close to having enough space. -5/3 times -33. Let's see. So times 24, 8, that's -56 plus 55. -56 plus 55. -1. Okay, and then the next one, we're looking at the second row now. So we're going to do -2/3 times 24 plus -1/3 times -33. And that's going to be -16 plus 11, which is -5. And that's all there is to it. Piece of cake, right? So yeah, there's a little bit of tediousness to it, but we are manipulating some matrices to solve an equation. X is some mysterious matrix, and now we know what it is. It's -1, -5. And then to put it into some context of mapping, if we had the point -1, -5, or the vector -1, -5 on a graph, so it'd be like that for you guys. Then this matrix in the blue, the original matrix, if we applied that as a transformation to that vector, and we're going to make it move, stretch, reflect, whatever, then where would it move to? It would move and become the vector 24, -33. So that's the transformation. That transformation takes -1, -5 to that new location. And let's do maybe number 23. Sound good? Yeah. Let's do number 23, or I'll tell you how to do number 23. So check this out. We can subtract a matrix. So we can subtract this whole matrix from both sides. So bye-bye -3, 6, 4, -1, 1, -5. And then bye-bye, we'll subtract -3, 6. Oh, my stars. 4, -1, 1, -5. And then what's the result of that? We'll do this bright purple color. So X is equal to these, we've taken away that matrix. So we subtract by address. -11 minus -3. So that's -11 plus 3, which is -8. Come on. Then we've got 0 minus 6. That's -6. We have 9 minus 4, which is 5. -6 minus -1, -5. 10 minus 1 is 9. -1 plus 5 is 4. And that's how you do number 23. And the last thing I'll say on this video is about number 26. So same process. We need to find the inverse of this matrix and multiply it by this one. So the inverse times this one. But let's think about what the size of B should be. So B is a matrix and it's our answer. Matrix B should be what dimensions? Well, this is a 2 by 2 matrix that we're multiplying by some unknown matrix. And the result is, don't turn off lights, is a 2 by 3 matrix. So if we want to multiply this 2 by 2 by something, the first number in that matrix has to be a 2, right? These numbers, this one, come on, and this one have to match. Okay, and then the outside numbers give us the dimensions of the new matrix. So B must be a 2 by 3 matrix that we're trying to find. Okie dokie. Again, there is good news because we have calculators. If we were to type in a way to check these, also you have the answers from the PDF, but we have this matrix. If I want to do the inverse of that matrix, kapow, oh wow. So there's the inverse matrix. So you can just get that using your calculator. And then we need to take that answer and multiply it by this matrix. The 2 by 3. -11. -11, -5, 14, 15. And we get that. What is this one? 26. So is that matrix B? It surely is. So calculator can do great things for you. And if you stuck it out and watched this video, now you know that. And that's a wonderful thing. All right, this is your assignment, your homework to be done by Friday. You'll notice there's some videos on Khan Academy that talk about what the determinant is and try to help you visualize that a little bit. Best of luck, and I'll see you on Monday.